Electricity is the silent force behind our modern world. It's an invisible current that powers nearly every aspect of our daily lives, often without us even realizing it. It powers our homes, lights our cities, and connects us globally. From the neon lights of bustling metropolises to the cozy glow of a suburban home, electricity is everywhere. Without electricity, life as we know it would grind to a halt. Factories would cease production, cities would plunge into darkness, and our daily routines would be upended. Imagine a world without computers, smartphones, or even electric lights. Our modern conveniences would vanish, leaving us in a state of confusion and disarray. It's a world we can barely comprehend. The absence of electricity would fundamentally alter our way of life. From the moment we wake up to the time we go to sleep, we rely on electricity. It's the backbone of our daily routines, seamlessly integrated into every part of our lives. Our alarm clocks jolt us awake, signaling the start of a new day. Our coffee makers brew our morning fuel, helping us kickstart our day with energy and focus. Our refrigerators keep our food fresh, preserving the ingredients that nourish us. We depend on electricity for everything, from cooking our meals to entertaining ourselves. But have you ever stopped to think about where this incredible energy source comes from? How it reaches us so effortlessly? How is it generated, transported, and delivered to our homes and businesses? The journey of electricity is a marvel of modern engineering. It's a fascinating journey that involves incredible feats of engineering and scientific ingenuity. From the power plants to the substations, every step is meticulously planned. Join me as we explore the electrifying world of electricity, from the power plants where it's born to the devices that bring it to life in our hands. Discover the magic behind the switch that lights up our world. The journey of electricity begins at power plants where raw energy is converted into a usable form. These plants are the backbone of modern civilization, providing the power needed for homes, industries, and infrastructure. There are several types of power plants, each harnessing different energy sources. From the burning of fossil fuels to the harnessing of natural elements like wind and water, the methods are diverse and fascinating. Thermal power plants are the most common. They burn fossil fuels like coal, oil, or natural gas to heat water, producing steam. This process is both efficient and powerful, making it a staple in energy production. This steam drives turbines, which in turn power generators. The turbines spin at high speeds, converting thermal energy into mechanical energy. Generators are essentially giant magnets that spin, creating an electric current. This current is then transmitted through power lines to homes and businesses. Nuclear power plants work similarly but use nuclear fission instead of burning fossil fuels. This method is incredibly efficient and can produce vast amounts of energy from a small amount of fuel. This process involves splitting uranium atoms to release tremendous heat energy, which also generates steam to drive turbines and generators. The controlled reaction is a marvel of modern engineering. Hydroelectric power plants harness the energy of moving water. By utilizing the natural flow of rivers, these plants can generate electricity with minimal environmental impact. Dams are built to create reservoirs, and water flows through turbines, generating electricity. This method has been used for centuries and remains a reliable source of power. Wind power plants use giant wind turbines to capture kinetic energy from the wind and convert it into electricity. These towering structures are a testament to human ingenuity and our ability to harness nature's power. Solar power plants use photovoltaic cells to directly convert sunlight into electricity. This clean and renewable energy source is becoming increasingly popular as technology advances. Geothermal power plants tap into the Earth's internal heat using steam from underground reservoirs to power turbines. This method is both sustainable and efficient, providing a constant energy source. Biomass power plants burn organic matter like wood chips or agricultural waste to generate electricity. This method recycles waste materials, turning them into valuable energy. Once electricity is generated, it needs to be transported over long distances to reach our homes and businesses. This is where the electric grid comes in, a vast network of transmission lines, substations, and other equipment that carry electricity across states and even countries. To transmit electricity efficiently, it's stepped up to very high voltages using transformers. These massive devices increase the voltage, reducing energy loss during transmission. The high voltage electricity then travels along transmission lines, which are typically mounted on tall towers to minimize interference. Along the way, electricity passes through substations, which act like hubs in the grid. Substations can step voltage up or down depending on the needs of the network. They protect the grid from power surges and outages. As electricity gets closer to its destination, it needs to be stepped down to lower voltages suitable for homes and businesses. This is done at distribution substations, which are smaller than transmission substations and located closer to population centers. From distribution substations, electricity travels along distribution lines, which are typically mounted on poles along streets or buried underground. These lines carry electricity to neighborhoods and individual buildings. Before electricity enters a building, it passes through a meter, which measures how much electricity is used. This information is then sent to the utility company so they can bill customers accordingly. Section 5, meters, switches and plugs, the final steps. Once electricity enters a building, it flows through a series of circuits, which are pathways that distribute electricity to different areas. Each circuit is protected by a circuit breaker or fuse, which shuts off the flow of electricity if there's an overload or short circuit. From circuits, electricity flows to outlets, switches and appliances. Outlets provide a convenient way to plug in devices, while switches allow us to control the flow of electricity to lights and other appliances. Appliances are designed to use electricity to perform specific tasks, whether it's heating our homes, cooking our food, or powering our entertainment systems. Each appliance has a specific wattage, which indicates how much electricity it uses. Section 6. The rise of renewables, harnessing nature's energy. For decades, fossil fuels have been the primary source of electricity generation, powering our homes, industries, and transportation systems. However, the environmental impact of burning fossil fuels has become increasingly apparent, leading to a growing demand for cleaner and more sustainable energy sources. The air pollution and greenhouse gas emissions from these traditional energy sources have contributed significantly to climate change and health problems. Renewable energy sources such as solar have emerged as viable alternatives. Wind, hydro, geothermal and biomass offer a promising alternative to fossil fuels. These renewable sources are naturally replenished and produce little to no greenhouse gas emissions, making them environmentally friendly. These sources are naturally replenished and produce little to no greenhouse gas emissions. They help in reducing our carbon footprint and mitigating the effects of climate change. Solar power has become increasingly affordable and efficient, making it a popular choice for residential and commercial use. Advances in technology have significantly lowered the cost of solar panels, making them accessible to a wider audience. Wind power is another rapidly growing sector, with massive wind turbines sprouting up on land and offshore. These turbines harness the power of the wind to generate electricity, providing a clean and renewable source of energy. Hydropower is a well-established renewable energy source, particularly in regions with abundant water resources. It uses the energy of flowing water to generate electricity, offering a reliable and consistent power supply. Geothermal energy taps into the Earth's internal heat, providing a reliable and sustainable source of power. This energy source is particularly effective in regions with high geothermal activity. Biomass energy utilizes organic waste materials, reducing landfill waste and providing a renewable source of fuel. This not only helps in waste management, but also contributes to energy production. Section 7. Smart grids, smart meters, a brighter energy future. As we transition to a more sustainable energy future, smart grids and smart meters are playing a crucial role in modernizing the electric grid. Smart grids use digital technologies to improve the efficiency, reliability, and sustainability of electricity delivery. Smart meters are a key component of smart grids, providing real-time information about electricity consumption. This allows utilities to better manage electricity demand, reduce waste, and integrate renewable energy sources more effectively. Smart grids also enable two-way communication between utilities and consumers, allowing for demand response programs and time-of-use pricing. These programs encourage consumers to shift their electricity usage to off-peak hours, reducing strain on the grid and promoting energy efficiency. Section 8. The Future of Energy, a Balancing Act. The future of energy is a balancing act between meeting growing energy demands and addressing environmental concerns. As we continue to rely on electricity for our daily lives, we must find innovative ways to generate and consume electricity more sustainably. Renewable energy sources will play an increasingly important role in the energy mix, but it's essential to ensure a reliable and resilient grid. Energy storage technologies such as batteries and pumped hydro will be crucial for storing excess renewable energy and providing backup power when needed. Energy efficiency measures such as building insulation, energy-efficient appliances, and smart home technologies will also be essential for reducing overall energy consumption. Section 9. Our Electrified World, a Legacy of Innovation. From the early experiments of Benjamin Franklin to the complex power grids of today, the story of electricity is a testament to human ingenuity and innovation. Electricity has transformed our world in countless ways, and its impact will only continue to grow. As we look to the future, we can be sure that electricity will continue to power our lives, drive innovation, and connect us globally. By embracing sustainable energy solutions and investing in smart grid technologies, we can create a brighter and more sustainable energy future for generations to come.